Welcome back, everyone. So we had a quick break, and now we are ready for our third talk already. So let's welcome Sarah. Sarah is a DevSecOps advocate and consultant at Araido, and she will start her presentation off with a question. Can you keep a secret? Sarah, the stage is yours.
Thanks, Kira. Hi, thanks for joining me today. Today we're going to be talking about can you keep a secret? And really what that has to do with is secrets management and how does that work within your DevOps organization. A little bit about me. I am, like Kira said, a DevSecOps advocate and secrets management specialist for Araido. And that really entails bringing that shift left and helping integrate DevSecOps and security specifically into DevOps. I also create a fair amount of content for their DevSecOps Academy, and I am a Hashicorp Vault enterprise trainer. Word to the wise, these views do not reflect my clients or customers, nor do they reflect Hashicorp. One of my mentors used to say, 3 can keep a secret if 2 of them are dead. And that holds exceptionally true when dealing with secrets management. And the reason behind this is because humans can't keep a secret. So there's a little bit of hesitation between what a secret is. So for the sake of this talk, we're going to clarify this. For us, the secret is a piece of information that we're going to use to authenticate and to authorize applications. They could be username and passwords, SSH keys, API keys, TLS certificates, especially the private side, private keys, all of these things that are used to communicate between processes and jobs. So at the end of the day, there's one reason that we need to keep a secret, and that's to protect our assets. Now, assets can be tangible things. They could be actual money. Assets can also be data, and assets can actually also be your reputation as a company. So here we're talking about personally identifiable information, financial information, medical information. It's also important to meet those regulator requirements because at the end of the day, that can have an impact on your liquidity. It can also have an impact on your reputation. To protect your servers from crypto mining. This happens more often than you think it would. And also to prevent those lateral moves within your network, because that, at the end of the day, allows you to move from asset to asset. Also, one thing we don't think about commonly are audit logs. Audit logs are a treasure trove for an attacker, and also system configs. It's just like handing them a map. So it's great, but really, what is secrets management? What's the big deal? What do we do? So what we do with secrets is ensure that there's a proper life cycle and that life cycle is controlled. And that's done in a way where it can be repeatable and ideally scripted. In order to do that, though, there are several things that we need to be able to accomplish. And that includes what needs to consume the secret. So are we talking about a service that needs to connect to multiple databases? Are we talking about microservices that just need to talk to each other? How is that secret stored? Is that secret stored in GitHub? Is that secret stored in something like KeyPass? Is that just hard-coded into your software? How is your secret rotated? So we all know that in order to improve our blast radius, it's important to keep that secret changing. And how you do that is also of equal importance. If you do that out in the open where many people can get that secret, yeah, maybe that's not how you want to accomplish that. Also, how often do you rotate that secret? Is it rotated every 90 days? Is it rotated every 10 years? When you get a secret, how do you initiate that secret? And how do you initiate that secret by keeping it secret? And the last thing, which I think is incredibly important, is how do you keep humans from seeing machine secrets? There's no need for a human to see a machine secret, and all that's going to do is increase your blast radius. So now, to further complicate things, what we're seeing is an infrastructure that's moving from this traditional data center. It's static. It has the perimeter, and it's referred to frequently as an M&M, right? So it has that hard shell, and then on the inside, it's much softer. But now we're moving to the cloud, and that infrastructure isn't the same anymore. There's no perimeter. It's multi-system, so you can have systems on AWS and GCP and Azure, but then maybe because of regulations, you also have that in your own private cloud. So how do you assure that those secrets are moving in a liquid fashion, but only as often as necessary between all of those things without being seen by human eyes? So we get it. It's complicated, right? There's no denying it. But what's the real issue then? Well, the issue is that you end up with something called secret sprawl, where secrets are just everywhere and you don't know where. There's no centralized solution. It's not like people are just going and putting them in KeePass or coming up with a solution to harness everything. Secrets frequently get hard coded in source code. I've seen it in multiple workplaces. Or likewise, secrets get committed to GitHub, which is almost even worse if it's in a public repo. We don't know how many people have seen these secrets. Could be 1, could be 10, could be 20. And then who's actually using that secret? Is it just you and your colleague? Or if you revoke that secret, is somebody in the cubicle down the hall going to scream because he just lost access? So if you still don't believe me that secrets are important, there's been a lot of news around it lately. Android, again, the GitHub issue with developers pushing to get their secrets to GitHub. AWS also saying, get your secrets out of GitHub. Crypto mining, again. And one that impacts me as an American is Equifax. They didn't even have the foresight to change their default password, let alone rotate it, keep it in a spot where it's secure or a centralized solution. But the good news is there are tools for that, right? So we have Hashicorp Vault, obviously. I'm a fangirl. We also have CyberArk Conjure. And there are more and more solutions becoming available as this rolls. So we have tools. We have an understanding now. But now let's talk policies, all right? So the issue here is that our tooling can only be as strong as the policies that we put them on and the solution that we put them on. So one really excellent place to start is taking an inventory, understanding what kind of technologies you have running, who needs to consume them, and also which platforms speak to which platforms, but also this principle of least privilege. So as a cybersecurity geek, this is something that is drilled into our heads over and over and over again. Only give the bare minimum of privileges that allows the user to complete the job. Don't give them more, don't give them less. You give them more, you're giving them too much permission. You give them less, they could actually end up DOSing themselves. So I've given you a little scenario here. You have an app, it needs to read to a database. That's it. Nothing else. It doesn't need to write, just read. However, what frequently happens with developers, and I am a developer myself and have been guilty of this, we give it a little extra permission just to be sure that the development process goes smoothly. It's a problem. So what we're going to see now, I prepared a little demo, and this demo is going to walk us through a Kubernetes implementation with Hashicorp Vault, and we're going to input a secret, and I've given it a vulnerable policy. And this vulnerable policy is on the incorrect path because we haven't been clear enough about which secret it needs to read. It has, it can read, it can write, it can delete, it can do everything basically. It doesn't have sudo, but you don't really need sudo very often anyways. So we're going to see what happens then when that happens. Now, to make sure we're on the same page, I've gone ahead and walked us through how to do the Kubernetes configuration here. As you can see, it's easy. We just need to export some environment variables to tell it where to talk to Vault and the authorization to talk to Vault. Now here we're going to tell it we want to use static secrets. We just want to be basic this time. And now we're going to tell it we want to write these secrets to the secrets/my_app path. That's important for later. And you can see with the return, it's version 1. So now we're going to write the Vault policy. And here we're writing it to secret with a wildcard. Now that means I can write, read anything to anything beyond that wildcard. Now I need to set up my service account. This is what my service account looks like. Ironically, I think Leanne is giving a talk on Kubernetes as we speak. But for this, you don't need to know what it is. This is going to bind it. And we've created our service account to make sure that it can authorize itself using the JWT. And now we're going to go ahead and apply that file that we just catted up above. And to be sure that everything worked according to plan, let's go ahead and get that service account. And you can see we've created the Vault auth service account, and it seems to be running. So what do we do next? Well, we need to tell it a little bit about our Kubernetes cluster. And this Kubernetes cluster has a server, it has its service account name, it has the JWT, and it has the CA cert. All of these things we need to pass to Vault because they're going to tell it how it can access the control plane and how the control plane can then speak back to Vault. All right, we have told Vault that we want to use the Kubernetes auth method, which just means that we can use the Kubernetes JWT token to authenticate ourselves and don't need to regenerate a token. So now we're going to go ahead and configure. We're going to send in that JWT, we're going to send in the kube server, and we're going to send in the CA cert that we set above in our environment variables. And then we need to tell it about the role. What is this thing allowed to do? It's a specification of the RBAC within Kubernetes. So we're just telling it's bound to the specific service account that we created. And most importantly, you can see that it has the policy myapp kb row vuln. And that's the one we created earlier that has too many permissions and allows you to do anything on any of the paths. So now, in an attempt to simulate an attack in about 5 minutes, I've spun up a pod that's just going to let me execute into it. So this pod is just going to allow us to make that simulation if an attacker were able to get access to your Kubernetes cluster. And I'm just going to do some housekeeping. We should be good to go. All right, so the first thing we need to know is that JWT token, right? Because if we're going to make an API call, we have to have some sort of authorization. All right, we've set that, and we've set that based off of the service account token. And then the next thing I have to do is set the Vault address. And you will notice that the kind folks at DevSecOps Academy are letting me exploit their system. All right. So let's go ahead and set that in there. All right, so now all we're going to do is log in. It's pretty simple, just an API call. And we're going to do that using a curl request with the kube token, and we're going to specify our role. Again, that tells us what policy we're allowed to use. Hey, cool, we have some information back, and we have some interesting information back. Here you can see the client token, and a client token is Vault's way of innately authenticating. So it generates this token every time you do an authentication request, whether you use Kubernetes or something else. So I'm going to grab that, and I'm going to set that. And now, really, I should be able to do anything, or at least anything that is specified within that policy. So let's give it a try. Now, let's go ahead and we're going to make that call and check out the data that we've already posted. We already know it's there. Oh, hey, that's recognizable. We set that up in the first step. Huh, okay. Well, maybe we can post some data now. That would be interesting. All right, let's post a new one. Oh, cool. All right, well, it looks like I just posted it. It tells me I have version 2. So let's go ahead and check it out. Oh, hey, yeah, it's there. Cool. Huh. I created some data. Nice. And it is indeed version 2. So now you're probably thinking, what can actually happen if we take this a step farther? So what I'm going to do now is I'm going to try to hit that destroy. And this is a destroy. This is not a soft delete. I cannot recover this later. And there you can see that if I get that information back, my data is null. I can see that it existed at some point, but it's not there. Well, I just deleted the one I created, so that's not really a big deal. But what happens if I delete that initial database connection? All right, it looks like it worked. Let's double check it. And there you have it. So as an attacker, I'm able to get in using my basic string and basic API calls. And because those authentication methods were too high, I could write secrets, which can be problematic, to be perfectly honest. I can also delete, but I can also destroy. Now, if I destroy your secrets, that's a problem. All right, so you don't believe me. I'm going to give you the UI because sometimes the UI is a little bit clearer about what's just happened. So again, we wrote that to secret, and it was under my app. Oh, hey, version 2 of this secret has been permanently destroyed. Huh, okay, there too. Okay, well, maybe if I go back into the history then. Check version 1. No, that's not there either. So what I'm telling you here is basically that if you wanted to get that data back, you would have to do some sort of system restore because that secret is gone. And that secret is gone because we didn't attach the correct policies to it. We need to be more explicit about the path. So where was that secret located? So instead of just doing the secret /star, what we needed to do was actually secret /my app. And really all this database is doing is reading. So there's no reason for this database to have had more access than read. All right, so how do we prevent this from happening? We've talked about don't do it, but yeah, how do you, in reality, what does that look like? Well, the most important thing you can do is know your requirements. What are your naming conventions? What secrets do your applications actually need to consume? Where are those secrets? Do they need to be on a specific endpoint? Do they need to be a specific method? How do you make that happen? And then when you're creating the policies, make sure you're using that principle of least privilege. Only give as much access as you need to and be explicit, right? So if you don't say, I need application X to talk to application Y, you're going to end up DOSing yourself. That's not going to be able to get in. And the last, probably the most important, is test. Test, test, test. Penetration testing, testing within your team, reliability engineering. All of these things are going to help show you actually how much blast radius are you going to have at the end of the day because of how much access you're giving your secrets and a potential attacker. So if you're interested in getting into a little bit more secrets and secrets management and understanding how it works, both in Kubernetes and integrating that into your applications, highly recommend, not just because I have authored some of it, DevSecOps Academy. So go ahead and check them out. And if you have any questions, let me know. Thanks so much.
Yay, welcome. Thank you so much. Thank you so much for your talk, Sarah. So we actually have one question. So what would you say is the biggest challenge or the hardest part for an organization to start implementing secrets management? Maybe from a development community perspective or organizational perspective?
Yeah, I think it really involves knowing your landscape. And I think the bigger the organization, the harder it is to know your landscape, especially once you start getting vendors involved and third parties. Yeah, also training the organization to understand that this is the way forward. This is how this needs to be handled. And yes, you've done this for X years leading up to this, but it's just not going to work anymore.
Okay.
Okay. And what do you think has been a really easy problem that you've been able to solve in this ecosystem of, secrets management? I know nothing is easy in the area of secrets management, but what would you say is the easiest?
I think the credential rotation is probably the easiest thing to solve. So you have various secrets engines that do this dynamic generation and dynamic secrets management. And basically, every time you connect, they just generate a new username and password. So what you see there is that blast radius is really shrinking, and the ability to get in is getting smaller also, especially for databases.
Yeah, that makes sense. The reason I asked that is because there's a lot of industries and a lot of enterprises that did not take the low-hanging fruit and just solve those problems first and start thinking of really complex and high-level solutions or high-level architectures without understanding what the basic problem is. So that's why I wanted to ask what you thought was something like a low-hanging fruit that they could solve first before, architecting really complex architectures and getting all these.
No, exactly. And this really solves your issue in terms of your 3 DBAs who have full access to your database, right? So we had Irene who was talking about insider threats last time. And this also kind of helps whittle that down because every time you have a new password that's generated and a new user that's generated, so only your app is consuming, and you know that no human is actually going to be able to get into that database. So everything else has to be done, through pipelines or scripting or in some sort of automated fashion.
Okay, yeah, right. Yeah, so thank you, Sarah, so much for your presentation, for your demo as well. I think that was really great for all our attendees. Thanks again. I hope you all enjoyed the talk, and we'll be back after a short break.
Hi, my name is Abel, Principal Cloud Advocate in